Assalamu alaikum, dear students. How are you? Good, mashallah. So, boys, here there are some practice questions. They are about the law of conservation of energy. So, we will solve today. They are very important questions. You must also practice about it. I hope you know about the law of conservation of energy. According to this law, that how we can state this law, that we cannot create or destroy energy, but we can transport from one place to other or between the system. We can change its form, but total amount remain the same. This is called basically law of conservation of energy, that we can energy transferred, usually stored, or it can be dissipated. Dissipated means it can be wasted. Okay, like in different systems, always there is a dissipator of energy. Almost no machine is available that has the efficiency of 100%. There are some ideal machines, only that one. So we'll solve these questions now. Let's see. This is Sankey diagram. This Sankey diagram represents what thing? If you read the label, input energy, useful output, and wasted. And the width of this arrow is proportional to the energy. Okay. Suppose that in this question, if you read, this is very important that you read the question, try to understand it. Because if you not understand the question, how we can answer it? It's impossible. Okay, let's see. The diagram represents the energy transfer for a device. Look, that is the input energy, useful output, and the wasted energy. The device is 50% efficient. 50% efficient means its half energy is wasted and half is useful. Both are equal, it means. So if we check our answers here, what will be our correct answer here? Input energy is equal to useful energy divided by 2. No, it's not possible because it's 50% efficient. This is an important point. It means that it's wasted and the useful energy are equal. So C will be your option, because wasted output energy is equal to useful output energy. Because 50% wasted, 50% efficient means half energy wasted and half is useful. They divided into two equal parts. Okay, let's see the 11 question, sorry. The diagram shows the energy transferred in a lamp in 1 second. Okay, how much is the total energy input? 100 joule. How much light out? 60. How much wasted in the form of heat? Oh, I already answered, 40 joule. So which type of energy is, which type of wasted energy? Okay, this is basically our dissipated energy is produced in the lamp. Like this wasted energy in what form? Like thermal, electrical, potential, what form it is? Chemical, not electrical, not, because electrical is the input for the lamp. Okay, light is useful output energy. So this waste energy is in the form of thermal, heat energy. Okay, this is the correct option for us. In the same way, if you look here, question number 12 here, a ball of mass. It's very important to read the question. This is the mass. Mass is given to you. These are the key quantities. 1.2 kg is dropped from a height of 30 meter. As it falls, 25% of its initial gravitational potential energy is transferred to thermal energy. But this energy, 25%, basically is a wasted energy. Okay, because it's waste, dissipated energy to the thermal energy. Okay, what is the kinetic energy of the ball just before it hit the ground? It is at the height. Whenever the object is at the height, what energy it has? Potential energy. So we have to calculate first of all what is the potential energy at the height. Then 25% will be wasted and the other will be changed into kinetic energy. So potential energy, how you will find it? Gravitational potential energy at the height when the object is, you will use this equation, mgh. M mean here mass, g mean gravity, h mean height. So what is its height? 30 meter. Mass is 1.2. If you put the values here, you will get the total energy that the object is at the height is 300 60 joule, and the 20% is wasted, 25%. So what is the 25% of 360? It is almost 90 joule. It means that minus 90 joule. This is the wasted energy. So what left? 360 minus 90. What left for us? Okay, this will be 270. That energy is useful. That change into kinetic energy. As any object is at the height, what type of energy it has? Gravitational potential energy. Okay, whenever it will fall here, it will go down like that, fall. There's a loss in the potential energy, but gain in the kinetic energy. Potential energy is going to change into kinetic energy when the object is falling down. Next is, and whenever it reach at the bottom, all the potential energy change into kinetic. Okay, number 13. If we ignore the air resistance and the dissipated energy, this is also the one thing. Some processes are more efficient than others. Which expression give the efficiency? You know this thing. Efficiency equal to what thing? Useful output over total input. So which one is his? Look, total energy output over total energy input. No. We only consider the useful energy output. Okay, so the useful energy output, so our option will be here B over total energy input multiplied by 100%. In this way you are able to find the efficiency. Okay, number 14. A lamp has a power input of 5 watt. It wastes 1 watt of power heating the surrounding. That is the dissipated energy. Okay, total input is 5. 1 watt wasted. What is the efficiency? Efficiency is equal to useful output. Look now, 1 watt of power is wasted. So what is the useful? 4 watt. And what is the total input? Because 1 watt is wasted. Total you gave it 5. 1 is wasted. So what left? 5 minus 1, 4 watt is the useful. Over total input. Okay. Multiply by 100%. In this way, you will be able to find its efficiency. So what will be your correct answer here? Your correct answer will be C. So by these type of questions, you must know how to solve. Practice them. This folder is available in OneDrive link that I send or share with you already. Okay. So please check your Outlook, email, and see that link. I will show you in the class also. And also, many times already we open in the class as well. Okay, now we'll see another question here. Look that. The figure below shows a rock that is falling from the top of a cliff. This is a cliff, okay? Into the river below. This is the cliff, okay? It's falling in the river. Here is the river. The mass of the rock is 75 kg. This is the important quantity, mass. Mass is which English letter? M. The acceleration of the free fall, the value of G is, free fall acceleration is 10 meter per second square. Calculate the weight of the rock. So how you will find its weight? Anybody can tell me please? Simple thing. The equation for the weight is W equal to mg. You will use this formula, this equation. Now substitute the values in it. What is mass here? The mass of the rock is 75 kg. So write here 75 kg. Okay. What is the value of G? Value of G is 10 meter per second square. So if you multiply 75 with 10 meter per second W, you will find the weight. W stands for here weight. Okay. So your answer will be 750 Newton. The unit of weight is Newton because weight is also force. So in this way you are able to find the weight. Number B part, sorry. The rock falls from rest. Whenever it is at the height here, it is in the form of rest. So here what type of energy it possesses? Anybody can tell me please? Whenever it is at the height, What energy it has? It has GPE. GPE stands for what thing? Gravitational potential energy. When it will fall, falling rock, this falling rock, okay, it has kinetic energy and also potential because it is at the height. But as it is falling down, potential energy is decreasing and the kinetic is increasing. Okay, look that. Rock falls from rest to a distance of 15 meters before it hit the ground. This distance that it moves total, okay, before hitting the water, the river, is 15 meters. Okay, calculate its kinetic energy just before hitting the work. Show you are working. You must show you are working here. How you can find the kinetic energy? Simple thing, you will use the law of conservation of energy. At the height, it has gravitational potential energy. When it will hit the river, all this potential energy, just before hitting the river, all this potential energy will change into kinetic energy. So here you will use a law of conservation of energy. Like, look, at the height it has potential energy. Whenever just before hitting the river at the bottom, this potential change to kinetic, but total energy remain the same. So energy can be transferred from one form to the other. Like in this example, at the height it has gravitational potential energy. When it falls, this gravitational change to kinetic. This is a transfer of energy, but total energy amount will be the same. Okay, so you will apply here law of conservation of energy. Look here, you can write here, applying the law of conservation of energy. You will write like that. Okay, applying the law of conservation of energy. You will use this relation. According to this relation, what we can write? According to this relation, kinetic energy at the bottom is equal to potential energy at the height. Both are equal to each other. So we will use this relation to find the kinetic energy at the bottom. So look, that kinetic energy at the bottom will be equal to potential energy at the height. So what is the potential energy at the height? Can you find it? Yes, easily we can find it. mgh, this equation you will use. So look, all quantities you have. What is m? What is the mass? 75 kg. What is the distance? 15 meter. It's given distance of 15 meter. And what is the value of g? Free fall, acceleration 10. So just put the values here and you will get your answer. What is m? 75. What is g? 75 kg. You must write here with the units. Okay, multiply by 10 meter per second. This is a free fall acceleration. This is, look, everything is given to you in the question. Just you have to read and understand it. And the h height is also given to you, 15 meter. So whenever you will multiply all these quantities, you will get it 11,250. What is the unit? Unit for energy is joule. This J stand for joule. Okay. Next thing, the water hits the water. Okay, before hitting it here, it has all kinetic, but whenever it hit the water, then where this energy go? What happened to the energy? What happened to kinetic energy of the rock during the impact? Whenever it just strike with the water, what happened? Number one is that you will listen the sound. So it means that some energy as the rock hits the water, some of its kinetic energy of the rock gets converted into sound energy. So sound energy of the splash on impact. Whenever this rock will just strike with the water, you will listen some sound. It means some energy has changed into sound energy. And the other part is that some of the energy will be changed into thermal energy as heat and water. And also, whenever the heat will rock the water, waves will be produced in the water. So it means that kinetic energy of the moved water, okay, or it makes waves. So this happened to the kinetic energy, okay. So you can write these reasons here like that. Number one, you can write that sound energy can I make it like that? Yeah, it looks nice. Sound energy of the splash on impact with the water. Okay, this is one of the use of the kinetic energy. Second thing is that thermal energy as heat in water. And the other thing is that kinetic energy of the moved water. So these are the different uses of boys. These type of questions, please more practice. If you have any problem, just email me. I will also help you. Okay, thank you so much.